online teaching platform. We are still looking at applications of differentiation in relation to small changes. All right. We have our eighth question over here, and we are to find a solution to it. An error of 9% is made in measuring the volume of a sphere. Find the corresponding percentage error made in measuring its radius. All right. Now we have two key concepts here. We have volume and radius. Okay. So considering the volume of a sphere and the radius of a sphere, we see that the volume depends on the radius. All right. So if an error of 9% is made in measuring the volume, it implies that there was an error made in measuring the radius as well. So we are to find the percentage error made in measuring its radius. Okay, so we have two key things that we have to focus on. We have to focus on the volume of the sphere and that of the radius of the sphere. But we have been given an important aspect to be the error made in measuring the volume of the sphere, which is 9% error. So that becomes the percentage error. All right. So we have our percentage error of 9%. That is percentage error of what? 9% in measuring the volume. So this is a percentage error in measuring the volume. So we know that to determine percentage error is going to be your error, the error that has been committed, right? Or the error made divided by the original value, that is the original, times 100%. All right, good. Now we have been given a percentage error made in measuring the volume to be 9%. So I'm going to replace my percentage error with 9%, all right, equal to the error. And the error is the same as the change. Okay, so the change in volume, the small change in volume divided by the original volume, all right, will give us, so let us look at it. So this is the original volume, will give us times the 100% be equal to the 9%. So we multiply through by 100. So it's going to take away the percent sign. And we are left with 9 equal to small change in V divided by the V, then equal to, sorry, multiplying 100. Okay. So here we are going to get it. We are going to get our, let us now cross multiply. So we are going to get 9 times V equal to 100 multiplying small change that has occurred in the volume. Okay, good. So we are going to get our small change in V to be 9V divided by 100. We are making the small change the subject. So we divide through by the coefficient of the small change, which is 100. Okay, 100. So we conclude that the small change, this implies the small change in the volume is 9V times what? Sorry, 9V divided by 100. All right. Now let us state the formula for finding volume of a sphere. The formula for finding volume of a sphere is V is equal to 3 divided by 4 pi r cube. All right, 3 out of 4 pi r cube. So this is the formula that we use to find the volume of a sphere. So we are going to now find the difference. Sorry, we are going to now determine the change that has occurred in the volume with respect to the radius. So we have dV dr will give us a result of 4 pi r square, meaning you are going to differentiate your V with respect to the radius, which is dV dr. Okay, good. Now, you know that our dV dr is approximately the same as the small change in V divided by the small change in what? The r, which is the radius. So we need to substitute this component into the formula. So we have our dV dr to be 4 pi r squared and our small change in V to be 9V divided by 100. So we have 9V divided by 100, all right? Then all divided by the small change in R. Let me write it well. It looks like it. Good. So now let us make the small change in R the subject. So we are going to now multiply, so we can rewrite it as 4 pi R squared, okay? Then multiplying the small change in R. I'm cross multiplying this over 1. So this multiply this and this also multiply this. All equal to 9V divided by 100, all right? So here we are going to get 4 pi R cubed because, all right, this multiplying the change, so it cannot multiply. So R squared, then small change in R in bracket, okay, all equal to 9V divided by 100, all right? So we can make the small change the subject now. So we are going to get it as small change. So we are going to now divide through by 4 pi R squared, okay? Good. So here to be 4, we are dividing through by 4 pi R squared so that we can make the small change in R the subject, because that's where will be, that's the value that you are supposed to get to use it for the percentage error in that same radius. So we need to first get the small change in the radius, okay? That's what we are looking for. Then you divide the 9V divided by 100 also by 4 pi R squared, okay? So here we are going to get small change in R equal to, here we are going to get it to be 9V divided by 100 divided by, or divided by 4 pi R squared, okay? Then we have our small change in R to be equal to 9V divided by 100 times 1. That is the reciprocal of 4 pi R squared, which is 1 divided by 4 pi R squared. Okay, good. Now, but we know our V to be 3 out of 4 pi R cubed, all right? So we are going to replace the V here, this particular V, with its component. So it's going to be small change in R is equal to 9 multiplying 4, sorry, it should be 4. Okay, 4 divided by 3. That is the formula rather. Let me check it. Okay, it will be 4 divided by 3. Good. That is the formula. There's a mistake here. All right. But the derivative is correct. It's 4 divided by 3 pi r cube. That's the formula that we use to find the volume of a sphere. Okay, let's continue. So we are going to substitute the value of V into the equation. So we have, where you see V, put its value over it. That is 4 divided by 3 pi r cube. Okay, in place of the V, this particular V, then divide by 100 times 1 divided by 4 pi r word squared. Okay, so this r squared can divide this, we are going to get the result of r, then the pi here also divides this. Okay, so we are going to get a small change in r to be equal to, now 3 here, 3 divided itself 1, 3 divided 9, 3 times, so 3 times 4 gives us 12. Okay, then we have r over here, so it's going to be 12r divided by 100 times 1 divided by what? 4. So this 4 divides itself 1, 4 divides 12, we are getting 3. So here the small change in r will be equal to 3r divided by 100. Okay, so our small change in r will be equal to 0.03r. 0.03r. Okay, now we have to find the percentage error made in the radius. So our percentage error in the radius is going to be the change in the radius over the original radius times what? 100%. All right. So the change in the radius is what we have obtained as 0.03, then divided by 0.03r, then divided by the original radius, which is the r, times 100%. Okay, good. So at the end, this cancels this. Okay, and we are going to get a result of, so we are going to multiply 0.03 by 100. It's going to be 0.03 times 100, okay, 10%. And at the end, we are going to get a result of 3%. So this is the corresponding percentage error made in measuring the radius of the sphere when an error of 9% is made in measuring its volume. All right. Thank you for watching.